Alrighty, we're back. Today we are going to be talking about some plate boundaries, and how they interact with each other, how the plates interact with each other, and what sort of boundaries we are looking at. Alrighty, so let's get into it. Let's go here. Okay, so we call this plate boundaries, plate tectonics, and it's the idea that the plates interacting with each other gives us a lot of formations on our Earth that are landscape features and that sort of thing. We have what we call 12 major plates that we could see on our Earth Science Reference Table. But there's also a lot more smaller plates mixed in there. But the 12 major plates and them hitting each other are things that we attribute to the three things listed here: earthquakes, mountain building, and volcanoes. We're going to talk about how all three of those happen today. So the three types of boundaries that we are going to be looking at are convergent, divergent, and transform. Now, just based off of the names, they should tell you a decent amount about what these plates are actually going to be doing as they hit these boundaries, and we'll talk about that right now. So let's do convergent. So the only thing that I wanted to talk about beforehand, I forgot this slide, is that the density of plates is actually varying between what type of plates they are. We call all plates, all of the large plates, two types, either continental or oceanic. Obviously, continental plates, the ones that make up the continents. Oceanic plates are the ones that the oceans are on. The oceanic plates are made of basalt and are more dense than continental plates, which are made of granite. Now, we've already talked about what they were made of in our first unit, so this is almost a little reminder. But the key here, the thing that you have to remember, is that oceanic plates are more dense. So when they hit each other, if one is going underneath the other, the one that's going to go underneath, well, that's the one that's going to be more dense. And so that's what we are looking at here in convergent plate boundaries. Now, convergent plate boundaries are when two plates hit each other and converge. Remember, we've talked about the word converge before. I like to often think about the Divergent movie series. While I've never seen it, I know exactly what it's about because it's somebody diverging, somebody going from the norm, somebody who's separating themselves from the pack. And so a divergent would mean moving away, where a convergent would be coming together. And so convergent plate boundaries are when two plates go towards each other. And so when we see this happening, depending on their densities, whichever one is going to be more dense is going to be diving under or subducting under the plate that is less dense. And so, well, let's see pictures of this. So here we have an oceanic, two oceanic plates. And so we see right here, this plate is moving into this plate and subducting, going under. Now, obviously, we have the hotter mantle as we go down. So as this oceanic plate is subducting, it's eventually going to hit the mantle and start actually melting. The rock is going to actually start melting. And so as that rock starts melting and starts rising to the surface, we have volcanoes being formed actually right here. And so I have a little infographic that even shows that right there. And so if we have, say, an oceanic crust and an older oceanic crust, the older one is going to have a higher density. And so that higher density is going to be subducting into the ground. And then as it gets to a higher and higher and higher temperature, eventually it's going to start to melt. And that melting rock is going to start rising, becoming lava. Magma going up to the surface to become lava. And so as it rises and builds up and forms and cools off, we get some volcanic rock, some obsidian maybe, and that volcanic rock keeps building up, building up, building up, and we have a line. So notice it is happening all along this line because this is happening all here. This is just one cross section of it. And so we have some island, some volcanic buildup right here. So notice how long this is taking. This is since we started 50 million years. It happens very, very, very slowly over a very long period of time. But when the Earth has been around for as long as We've seen it or have observed the evidence of it changing. Things like this do build up. And so that is oceanic convergent boundaries. We can now look at oceanic continental, which is very similar in many, many ways. We still have subducting ocean plates going down underneath. Up we have rock melting, and now we have some more larger mountains here. So we have, because of this continental crust, we have a little bit more, actual mountains being built. And so we could show that as well. Let's see. I'm going to throw an oceanic crust on the left, a continental crust on the right. As these two converge, coming together, the oceanic goes underneath. Eventually it'll start to melt once we get to a higher temperature. And so that'll rise. Now if we speed it up a little bit, we'll have that uplift and mountain ranges. Alrighty. Not too shabby. Alrighty. And then continental, same idea here. Once again, we have mountain ranges being formed. Same idea. One plate they're going into each other, one plate subducts based off of it being denser, and mountain ranges forming. So, let's move on to divergent plate boundaries. So if convergent plate boundaries are when the two come together, divergent plate boundaries are when the two plates separate or diverge. And so what we see here is things like a mid-ocean ridge, where we have two plates separating from each other, and the magma actually being able to come up in the middle of them. And so what we'll see here is that these two plates separating from each other, as the magma comes up to the top, comes up to the surface, well, what does that magma do? Well, it's going to cool off, it's going to become new rock, and then it's going to continue outwards. And so you'll see that the rocks on the outside of the mid-ocean ridges will be older, and the rocks on the inside or close to the center will be younger. And that's a really, really key point, that the rocks on the inside, the ones right near the middle, are younger than the ones on the outside. And so we could also show that. Here. Do some new crusts, throw a young and a young. So now we have a divergent plate. So as they separate out, the magma comes up and forms new rock here. Now that new rock here eventually is going to be moving outwards. So we have older rock, newer rock. And that new rock gets formed and then moves outwards. New rock gets formed, move outwards. New rock gets formed, move outwards. And this continually happens. Cool. And last but not least, transform. So now this one isn't as intuitive to figure out. And so a transform is when the two plates, instead of going towards each other or away from each other, they actually slide side by side. And so they're actually sliding past each other. Whoops. And so they'll look a little something like this. Now what this does, while it might not build mountain ranges, the key thing that it does is cause earthquakes. And so as the two things slide, because it's rock, they don't slide very smoothly. A lot of times they'll get caught on each other and then all of a sudden like quickly jolt or quickly slide just out of nowhere. And so those slides can often cause earthquakes. And you might ask yourself, well, where does this happen? Well, a common place that they love asking in the United States where it's happening is the San Andreas Fault in California. This is why California gets so many earthquakes, and because we have this transform plate right here, right along the San Andreas Fault. And so as these two slide, if they catch on each other, or if they slip, oftentimes that's where we can get our earthquakes. And that's often why it's very hard to predict when an earthquake's going to happen, after it happens, we can figure out where it has happened or where the slip occurred. But it's a really hard thing to say, oh, we're expecting an earthquake in July of 2020. It just doesn't work like that because we don't really know exactly when it'll slip. And so that fault, that transform fault, we can also show here. So let's see if we could do, let's do 2 continental crusts. We'll do a transform fault. And so as they slide, that motion is where they can slip and cause earthquakes. Now, it doesn't affect the landscape features as much. You will see that some rivers can show transform faults. Very similar in this picture. So you'll see this river comes in, and then all of a sudden, instead of the river continuing forward, you'll see it cut along the fault and then go back out. So that's one way that you could see where a transform fault might lie. But other than that, there's not many landscape features that actually show transform faults. So we've done convergent, divergent, and transform plate boundaries. We're going to be building on why these plates move next week, so we know what happens when these plates hit each other. But next week we're going to be looking at, well, why do they move? Like, what is pushing them to move? Alrighty, see you guys later.